Assalamualaikum and good morning. My name is Nurul Afifah binti Muhammad Kamal Rufadzil. Today I'll be presenting FYP presentation entitled In Silico Study of Allergenicity and Antigenicity of Dengue virus using predicted epitopes. Start with background of study. The primary vector of dengue virus is Aedes aegypti mosquitoes, which are members of the Flaviviridae family. There are 4 serotypes of dengue virus, which are dengue virus 1, 2, 3, and 4 serotype. According to Malaysia Deputy Health, Malaysia records 19 deaths in 2021 to 44 deaths in 2022 for dengue cases. The fatality rate of dengue cases increased by 131.6%, and vaccine is the most appropriate and cost-effective way to treat and fight against the disease. The problem statement: traditional vaccine development can take up to 15 years and involve experimental preclinical studies. The advancement of in silico approaches are incredibly beneficial in developing modern therapies such as developing epitope-based vaccine. Allergenicity and antigenicity test is significant to enhance the safety, effectiveness, and practicability of immunotherapy, especially in designing vaccines. There are 3 objectives. Firstly, to investigate the allergenicity characteristic of dengue virus using in silico approaches. Secondly, to investigate the antigenicity characteristic of dengue virus using in silico approaches. And the last is to explore the application of computational biology in vaccine development of dengue virus. For literature review, first is epitope-based vaccine. The selection of appropriate B-cell and T-cell epitope trigger both humoral and cellular immune response, and to determine how well a subunit vaccination is effective. Epitope-based vaccine for influenza virus successfully developed as protective universal vaccination based on peptide shared by all strains of influenza. Next is allergenicity. Allergenicity is the ability of antigen to stimulate an abnormal immune response, also known as allergic reaction. However, antigenicity refers to the capability of epitopes or antigenic determinants interact with B-cell receptor. Next, we move to flowchart of methodology. Both allergenicity and antigenicity tests use predicted dengue virus epitope obtained from previous study. Allergenicity tests use ALLERGENICITY server and verify using ALLERTOP, while antigenicity tests use Vaccigen server and verify using IEDB from Kolaska and Tongaka method. Then, let's discuss the result and discussion. This study used 2 epitopes, which are epitope 12 and epitope 15, represent 4 countries in Southeast Asia, gained from a previous study using BabyPrep, SVM-Trip, and BCPrep server, and was analyzed using web logo and epitope conservancy analysis tool. This epitope has potential as biomarker for detecting dengue virus group. For allergenicity test using ALLERGENICITY, table 4.2 show the result obtained for both epitope 12 and 15 of dengue virus is non-allergenic by indicating the score of negative 0.5498 and negative 0.4276 respectively, with the default threshold of negative 0.4. The score is lower than the threshold, which indicate non-allergen and can be considered a positive result from a safety perspective. From the previous study of Nipah virus, the predicted sequence of Nipah virus was determined to be non-allergenic with a default threshold of negative 0.4. The predicted ALLERGENICITY score was negative 1.6635. Move to verification of allergenicity using ALLERTOP. Table 4.3 show the result obtained for both epitopes 12 and 15 of dengue virus has been verified as non-allergenic using ALLERTOP server. In the previous study of the monkeypox virus, the result obtained was non-allergic. For antigenicity test using Vaccigen, the score for epitope 12 is antigen due to a higher score 0.7534 than the default threshold 0.4, while epitope 15 indicated non-antigen, which is 0.1135, showed the lower score than the threshold. From previous study of Zika virus, the overall score for Zika virus epitope was 0.7522, indicating that it could serve as a probable antigen which greater than threshold. Next, for verification of antigenicity using IEDB Kolaska and Tongaka method, the threshold for average antigenic propensity for epitope 12 is 1.026. Peaks above the threshold show antigen and below show non-antigen. From this graph, we can see more region of sequence is higher than threshold indicate result as antigen. Table 4.5 show the predicted antigen for epitope 12. The score value was compared to table 4.6. 8 position show the score of antigenic while only 6 position show score of non-antigenic. The result is antigen due to high number of position residue contain greater score than the default score of amino acid in table 4.6. The result show the antigenic components can be recognized as foreign by the immune system and trigger an immune response. The threshold for average antigenic propensity for epitope 15 is 1.045. Based on the peaks, more region of sequence is lower than threshold indicate the result as non-antigen. Table 4.7 show the predicted antigen for epitope 15. The score value was compared to table 4.6 occurrence of amino acids in epitopes. 8 position shows score non-antigenic while only 6 position shows score antigenic. The result is non-antigen due to high number of position residue contain lower score than the default score of amino acids in table 4.6. Non-antigenic meaning it is failed to induce a significant immune response or do not trigger an immunological response at all. The study focused to investigate allergenicity and antigenicity to dengue virus peptide epitope 12 and 15 using bioinformatic approach. The objective of this study was successfully achieved. Allergenicity tests of epitope 12 and epitope 15 using algebraic show non-allergen that considered safe to use for further vaccine production. Antigenicity tests for epitope 12 indicate antigen which can trigger immune response and produce antibody, while epitope 15 show result of non-antigen that fail to induce a significant immune response. Therefore, epitope 15 is not safe for further vaccine production. Lastly, the additional bioinformatic tools and experimental approach to test the allergenicity and antigenicity of dengue virus must be considered and supported by lab experimentation. Thank you.